Now we look at absolute minima and maxima of functions of several variables. Like in the single variable calculus, if you want to find absolute maxima and minima of a continuous function on an interval, you look inside the interval to find local maxima and minima, and then you look at the boundary points and compare the boundary points to those values which you already found. Now, if you have a function of two variables like here, f of x and y, then the boundary is not a point. The boundary of this rectangle would be the boundary sides, the edges. But the principle is the same. We look at the inside and then we look at the boundaries. So what do we have to do? Find the inner critical points and evaluate f at those points, and then find the extremal points along the boundaries, and then find the max and min for those points. Let's start with the inner critical points. Remember, the critical points are the zeros of the partial derivatives. So let's do the partial derivative. If I differentiate by x, I just get 4x. If I differentiate by y, I get 2y. Fx partial derivative is 0 whenever x is 0, and the y derivative is 0 whenever y is 0. This implies we have exactly one critical point inside the domain, which is 0, 0. And then for later use we can evaluate already f at 0, 0, which is equal to 4. So we don't know yet if this is min or max. We could use a discriminant to find local conditions for min and max. But let's skip the discriminant and just go right to the boundary points. Look at f along the boundaries. So let's plot the domain. We have a rectangle. And now here is 1, here is -1, here is -1, and here is 1. And now I enumerate the boundary. This is L1, this is L2, this is L3, and this is L4. So on L1, I have y is equal to -1, and x is variable between -1 and 1. On L2, here I have x is equal to 1, and then y varies. On L3, up there, I have y is 1, -1 less or equal x less or equal 1. And on L4, down there on the left, I have x is -1, and then -1 less or equal y less or equal 1. These are the four boundaries. And on all of these boundaries, we need to look at the function f. So let's do L1 first here. So on L1, we have y is equal to -1. So I just sub in the -1 for y. What remains is just a function of x. 4 plus 2x squared, and we sub in the -1 for the y, so that's another +1. So this is 5 plus 2x squared. And x runs between minus and +1. So now for this function, we need to find absolute maxima or minima. It is a parabola, which looks like this. So here is -1, here is 1, and this is 5 plus 2x squared. So it clearly has a minimum at 0, f at 0, so this would be 5, and it has a maxima value at the boundary of this interval at the points +1 and -1. I just write this as +-1 just for short. If I sub in 1, then I get 5 plus 2, which is 7. Let's do the other boundaries. So on L2, I have x is equal to 1, and then the function remains a function of y. When I sub in x is 1, I get 6 plus y squared. Again, a parabola which is smallest for y is 0. So then we have a minimum value at 0, which is 6, and we have a maximum value at plus or -1, which then is 7. On L3, this is on the top, we have y is equal to 1. So then we keep a function of x by subbing in the y, which is 5 plus 2x squared. That's the same we studied already, so then we have the minimal value in 0, which is a 5, and the maximum value at plus or -1, which is the 7. And then 4, that was on the left where x is -1. So then we get a function of y, which is the same as before, 6 plus y squared. And again, we have a minimum and a maximum at plus or minus 1. And now the third step was to take the inner points which we found and the boundary points which we found and compare all of those. So this I've done here in this table. I show the region L1, L2, L3, L4 and the inner point at 0, 0. And then these are all the points I found, and these are all the values for f which I found. I just can read the result. So this is the absolute minimum. And then the 7s here are the maximal values. Let us use Wolfram alpha to look at the function. Yeah, here you see it. So very clearly this is like a parabola thing. It has a minimum in the middle, which we found out to be equal to 4. And then we have 4 maxima on the sides, these tips here, where the function is equal to 7. And here is the contour plot, which also shows very clearly a minimum here, and then local maxima right there on the edges.